In this video, we're going to look at the transformation of quadratic functions. We have 3 paper handouts, and what you need to do with each handout is the following. So you're given, each handout is one piece of paper. So what you need to do is you need to take the side that says the information that's on the outside, and you're going to fold it into the inside like this, and then fold the other side over. So when you're done, you'll be able to stick this inside and have a trifold. You're going to do that with every piece. The other thing you need to make sure is that if the printer cut off information here on the side margin, you need to make sure you complete that. So it should say parent function, the vertex, the general equation, written. This should say f at x, vertex, f at x, transformation, f at x, where, and so on. You can see how you need to fill that in. Make sure that that's completed. Okay, so after you've gotten your trifold folded, please let's look at the parent function. So the parent function of a quadratic is x squared. So let's just do a couple things here. Let's open this up to this inside flap, and we're going to write quadratic function. Okay, so you're going to write quadratic function, and we're going to write a couple things with quadratic function. First, we're going to look at what's called standard form, and standard form is y is equal to ax squared plus bx plus c. So now, if I want the parent function, there's a couple things that I must have. First of all, I have to make sure the highest degree is there. This is a degree of 2. The other thing that I have to make sure I have is the base that goes with that, which is x. And then the last thing is that this value of a right here is going to be 1. So that would give me my parent, which would be y is equal to 1x squared. So you see all of this is just kind of extra, so the parent function doesn't have that extra. We can simplify 1x squared as y is equal to x squared. The other thing that you need to remember that y is the same thing as f at x. So I could also write the parent function as f at x equals x squared. These two mean the same exact thing. They're both the parent function of the quadratic. So now that we understand that, we're going to talk about the transformation. So this format should look familiar to you since we've done the absolute value. Or even if you did a linear transformation, this form should look somewhat familiar. So now we're going to investigate what that form does. So looking here just at the parent function, let's make sure that we know what that parent function is. So we're going to come back and fill this out in a minute. We remember, let's start with the with our table and then our graph, and then we'll come back. So remember that my function is the same thing as y equals x squared. So we have to square this. So we're going to put negative 3 and we're going to square it, which gives us 9. Negative 2, and we're going to square it, which gives us 4. Negative 1, and we're going to square it, which gives us 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. If you can't remember how I got those numbers, just remember squaring is the same as having a multiplicity twice. So that's all we're doing. If you can't remember how to square, we're taking the multiplicity of this 2 times. Okay, so let's graph these points. So we have the point negative 3, 9, negative 2, 4, negative 1, negative 1, 0, 0, 1, 1, 2, 4, and 3, 9. So this actually makes a curve. So the way I start to graph it is I draw like a bowl, and then I continue to curve up, and I try to hit those points the best that I can. Okay, so this here is our parabola, and our vertex is right here at 0, 0. So notice I said highlight the vertex. So our vertex is right here at 0, 0. That's really important. Let's go ahead and label this. Vertex, which is at 0, 0 for our parent. Okay? So that's really important because this vertex is going to help us with our transformed function, with our what's called vertex form. So let's look over here. It's asking for the vertex of the function. So the vertex comes from our graph at 0, 0. So if you remember, our vertex is our HK. So HK is the vertex. Okay? So that means this is the same as HK. And I'm going to color code this again. I'm going to make H in yellow. Oops, I got ugly. And let's do K in pink. Okay. So if we're looking here, notice my H is always inside that parentheses that's being squared. So this is my H, and this is my K. Okay. So let's put that in. H is 0, and K was also 0. And A, I didn't tell you what A is, but we should know what A is because A exists right here in the very front. Right here is where A is. And if I don't see any number there, I understand that to be 1. So that means A is 1. And I'm going to highlight that also in orange. So those are all the things that you need to understand when you see x squared. The vertex is 0, 0, our HK, and the lead coefficient is 1.